Hello and welcome to today's chemistry class for beginners. Today's class we are going to deal with chemical bonds. And as usual, before we proceed with the class, I would like you to please subscribe, like, share and comment, as this is what will enable us to do more for you. Now, I don't know if you have ever wondered why chemicals react. Have you ever thought about it? Why do atoms combine? How do they combine? What conditions lead them to form bonds? Atoms combine so that they can attain a stable duplet or octet. We are going to explain what duplet or octet means. But essentially, this is the main reason why atoms combine. Atoms become unstable when they do not have a stable duplet or octet. Hence, they do any of the following in order to gain stability. But meanwhile, all elements want to attain that stable duplet, meaning 2 electrons in the outermost shell, or octet, meaning 8 electrons in the outermost shell. Now, atoms can either lose electrons, gain electrons, or share electrons in the process of trying to form bonds. Lose electrons, gain electrons, or share electrons. Atoms combine by forming different kinds of bonds. Chemical bonds are attractions between ions, molecules, and atoms that lead to the formation of a chemical compound. There are 2 main types of chemical bonds. A. Strong or primary bonds. B. Weak or secondary bonds. The strong or primary bonds include covalent bonds, ionic bonds, which are also called electrovalent bonds, and then metallic bonds. The weak or secondary bonds are hydrogen bonds and van der Waals forces. There could be other bonds, but we are sticking to the low ones, to the basic ones rather. Now let's take a closer look at all these bonds, one after the other. The first one is covalent bonds. What are covalent bonds? Covalent bonds essentially is a bond that is formed due to sharing of electrons between participating species or atoms. Anytime you hear the word covalent, always think about sharing. There are 2 types of covalent bonds: ordinary covalent bonds and dative covalent bonds. Just remember that all covalent bonds means sharing of electrons. In ordinary covalent bonds, both participating atoms contribute the shared electrons. Remember, both participating atoms contribute the shared electrons. What this means is you bring, I bring, we share. You bring, I bring, we share. The 2 small circles at the intersection of the nucleus shows the 2 electrons that are being shared, contributed by each of them. Take a look at this other slide. The blue circles are for hydrogen, while the red one are for carbon. And you can see how each contributes 1 and they are being shared to form CH4. This is H2. You can see how the 2 hydrogens contribute 1 electron each and they share it. The other type of covalent bond is the coordinate covalent bond. It is also called dative covalent bond. In this bond, The difference is not much. In dative covalent bond, only one of the participating atoms contributes the shared electrons. Only one atom contributes what is being shared, meaning that you bring, I do not bring, but we still share. You bring, I don't bring, but we still share. You can see a good example. The coordinate covalent bond is what the arrow is pointing at, where there are two blues. The two electrons are being contributed by the nitrogen nucleus. This is another one. The bond with the broken lines is showing that nitrogen is contributing while hydrogen is not contributing. That arrow is also showing you the coordinate covalent bond, where hydrogen is sharing with nitrogen even though hydrogen is not contributing. The ionic bond is also called electrovalent bond. That is the next bond we are supposed to look at now. In ionic bond, the force of attraction between the positive and the negative ion is referred to as ionic bond. Don't forget we said it is also called electrovalent bond. Atoms with 1, 2, or 3 electrons in their outermost shell usually lose those electrons to form positive ions. They form +1, +2, or +3 ions depending on the number of electrons that they have just lost. So if it loses 1 electron, it is +1. Atoms with 6 or 7 electrons in their outermost shell usually gain 2 or 1 electrons respectively to become a negative ion. The ions become -2 or -1 depending on how many electrons they have acquired or they have gained. So if you have a situation where you have nitrogen and chlorine nearby, nitrogen can easily give away its 1 electron in the outermost shell to become Na+, while chlorine will receive the 1 electron to become Cl-. Now you can see the transfer of electrons. The pull between the two ions is what we refer to as ionic bond. In metallic bond, the metallic bond is the force of attraction between a negatively charged delocalized electron cloud and their positively charged nuclei. This metallic bond is a very tricky one. You need to pay very good attention in order to understand how it works. The electron cloud is like a sea of electrons, like a soup of electrons, like a cloud of electrons. The electrons is expected to revolve around its nucleus. In our elementary chemistry, we have been told that an electron will revolve around its nucleus. That is what is expected. That is what we should see. But in metals, electrons jump from their orbit around their nucleus to a nearby nucleus, thereby repelling the electron in that other nucleus that they have just jumped into. The electron that was originally there is repelled. The original resident electron that was pushed away jumps to yet another nucleus, equally repelling another resident electron. If you understand it, 1 electron has jumped from 1 nucleus. Think of your assembly line in school. When someone, imagine you standing in a straight line and 1 person pushes forward, everyone on that line tends to fall forward. This is what happens when an electron jumps from its nucleus to the next nucleus. Simply because 1 electron has jumped, you will see all other electrons just moving. That's why we refer to them as like a cloud, like a sea, like a soup of electrons. These slides will just show you can see how the electrons they are supposed to be revolving around their nucleus, but they seem to be free. They are delocalized. They are free. So they move around and jump from 1 nucleus to the other, thereby pushing the one that was there initially, and that one also moves and repels the next, and based on that you now see a sea of electrons moving. Now the pull between that sea of electrons, or between the cloud of electrons and all those positive nuclei below. The pull between them is what we refer to as metallic bond. Now let's go to hydrogen bond. That's the next. In hydrogen bond is the force of attraction between the negative pole of one dipole and the positive pole of another dipole. Please take note of that. The positive pole of one dipole and negative pole of another dipole. Now, hydrogen bond is a very weak bond and can easily be broken by heat. Very easy. It can be broken by heat. A dipole simply means two poles. Dipole, two poles. That's the meaning of a dipole. A negative pole and a positive pole. Two ends. You can see on that slide. A negative pole and a positive pole. So when there are up to two dipoles, one side will have a negative, the other side will have a positive. The pull between the positive pole of one dipole and the negative pole of another dipole, you can see it with the broken lines, is what we refer to as hydrogen bond. Here you can see the formation of the dipole, a negative and a positive pole. They are both partially negative and positive. And you can see an example. The pull between the two dipoles is what, of course, we refer to as hydrogen bond. Again, hydrogen bond can be intermolecular or intramolecular. Intermolecular within the molecule, intramolecular outside the molecule. The next is van der Waals forces. And van der Waals force, of course, is another very unique force which is very weak. And you need to pay attention to understand what the force is all about. Van der Waals forces are forces of attraction between two discrete molecules. What this means is two molecules that are not touching themselves, but there is a pull between them. Van der Waals forces are very weak forces and are easily broken by heat or increased distance between the molecules. Once you do that, you easily break van der Waals forces. You can see an example of the molecules standing apart. They're not touching themselves, yet there is a pull between them, an interplay of forces between the protons and the electrons of both ends, of both atoms. Van der Waals forces, like we insisted initially, are very weak. At this point, we are coming to the end of today's class. I would want you to please subscribe, like, share, and comment. And like I told you at the beginning of this class, your subscription is what helps what we do so that we can do it and do it well. Thank you, and see you in the next class.